Welcome. This is lecture series for ordinary differential equation, and this is the lecture number 5. We have already made some video in this topic. You can go there and watch. So I hope you have already know what is differential equation and what is solution of a differential equation. In this topic, we will know initial value problem and boundary value problem. That means this problem is related to finding solution of a differential equation, but you will give some condition that will be initial condition, that may be boundary condition. Okay, using that condition, we will find that particular solution. If so, let us consider this is a differential equation dy by dx is equal twice x. Suppose we know what is the general solution. We have find in lecture number 4 what is the general solution of this differential equation. This is a differential equation, and I hope you know what is the solution of this. We need a function whose derivative is twice x. A function will be y is equal to x squared. Derivative of this function is twice x. Okay, so it is a solution of this differential equation, and whenever you add some constant, this is arbitrary constancy there, then it is general solution of this differential equation. Okay, now you are given some condition. You have to find the solution of this differential equation such that this is a differential equation. You are in your problem. In your problem, you are given that find the solution of this differential equation dy by dx equal twice x such that यहाँ पे कुछ condition दिया है y is equal such that y of 1 at x, that means at x is equal to 1, the value of y, this means at x is equal to 1, the value of y is equal to, let us suppose 4. You can write here 5, 6, 7, 8, whatever you know. You can make this is 100 also you can write. So we need the solution such that in that solution, when you put the value of x is equal to 1, you will get y is equal to 4. So this is one condition is given at a point. What is 1? This is 1. So 1 is a point where the solution is defined. So this is a, okay. Now we need, the question is that find the solution of this differential equation whose value at x is equal to 1 is 4. So this is a initial value problem because we are given, so we are given an initial condition. This is called initial condition. That is we have to find a solution of the given differential equation whose value at x is equal to 1 is 4. Okay. Okay. Clear? Is it visible? Since the general solution of the differential equation, what is the general solution? We need such a function y such that the derivative of y is equal to twice x, that is x square, derivative of x square is equal to twice x. So the general solution of the differential equation is y is equal to x square plus c. In the next lecture, after 2 3 lecture, we will we will know how to solve differential equation, how to solve exact differential equation, how to solve non-linear differential, how to solve linear differential equation, how to use method of undetermined coefficient. Yes, we will know. We will discuss every method of finding solution. But now this is nothing to be uh, think that this is not, you don't mind, you also know this is a solution of this differential equation. And but our aim is what is initial value problem. We have to know that. Okay, so according to initial value, condition according to condition given, that is initial condition, y of at x is equal to 1, y of is equal to 4. This will imply at x is equal to 1, put x is equal to 1, 1 square. This will imply put y of 1. Yeah, y of 1. That means x is equal to 1 put for 1, 1 square plus c is equal to 4. Here this will imply c is equal to 4 minus 1 is equal to 3. You will get c is equal to 3. That is, we now put the value of c here. Hence, the required, hence the required solution of this initial value problem is y is equal, you have to put here x square plus 3. So this is the required solution of this initial value problem. So this is just an example to think what is initial value problem. Now we will generalize this concept to any differential equation of order 1. So let us remove this. Consider the first order linear ordinary differential equation dy by dx is equal f of x. This is a general. This is f of x may be anything. So this is general case. This is a general differential equation. That means this is a differential equation. This is okay. The function will be anything, any function. F is continuous function of x and y. Where where f is a continuous functions of x and y. The general solution, let the general solution is differential equation is, so y is equal f of x. कुछ भी हो सकता है, Yeah, so capital F. Solution is a relation. Solution is a function of x and y. So capital F of x and y. That means this is a function. Solution is a function. Y is a capital F of x, y. And general solution, that means you here an arbitrary constant c also here. Capital F of x, y, c. And let the initial condition is y of x naught is equal to y naught. That means at x is equal x naught, when you put here x is equal x naught, you will get y is equal y naught. So this is a initial condition. That means y is equal x naught, y naught. If that means at value at is equal x naught, y is equal to y naught. That means graphically this is, if this is a function y is equal to x square, suppose y is equal to x square, it is a function, suppose. So this the function is the graph of the function, this solution of, okay, y is equal to x square, suppose the function is this is solution of what? This is solution of, in the previous lecture we have discussed about the solution dy by dx is equal y6. We have discussed what is the geometrical meaning of the solution of this differential equation. The solution is this, general solution of this differential equation is this. This is the general solution of this differential equation. And when we keep changing the value of c, we obtained one solution, one particular solution. And that particular solution is a graph. When c is equal to 0, the graph is passing through this 0. This is a parabolic graph passing through 0, 0. When c is equal to 1, it was the graph this. Now, initial condition, that means you need that solution. These are infinitely many solutions. Initial condition, that means it will help us to find a particular solution. That means at y is equal to x naught, the value is y naught. That means we need the solution which graph is passing through y naught, passing through the point x naught, y naught. This is the passing through x naught, y naught, whose graph is passing through x naught, y naught. That means the value of the function y is equal to y naught when x is equal to x naught. That means this is the point x naught comma y naught. That means the graph should be passing through this point. Let us suppose this is x naught. Here this is x naught, and this is y naught. Passing through this point. This point is geometrically. So this is the point x naught, y naught. Let us suppose this is the point. Okay. This is the point. So we need that. And the initial condition is this. Now come to this problem. So this is the solution and this is the initial condition. Initial condition is this. That means this initial condition, after applying this initial condition, we will get the particular solution, and y is equal f of x naught, y naught, c. After putting this in this relation, put x is equal to x naught and y is equal to y naught. Then you will get value of c from this relation. Let us suppose that you have obtained c is equal to c naught. Let us, okay. So you putting values from, okay, putting we obtain. So this is the initial condition we obtain using this initial condition. We obtain this, इसको यहाँ पे apply किया. We have applied this initial condition here and we get this. So you will find from this, from y is equal to f of x naught y naught c, we get c is equal to c naught. That means from here you will find the value of c. Suppose the value of c is c naught, say. Our aim is to find this arbitrary constants, value of this arbitrary constant. So we have find c naught. Hence, required solution will be y is equal, put in the general solution, f of x y, in place of c you will put c naught. So this is the particular solution, because we have put a particular value of course c. But what particular value we will put here, that will be given by this initial condition. That will be depend upon this initial condition. So I hope you understand that is initial value problem. Now we will go to boundary value problem. Boundary value problem, that means you are given two initial conditions. Here this is a problem. Initial condition was y of 1, so y of x naught is equal to y. This is an initial condition. One more initial condition also be given after differentiating the function. After differentiating the function y, you put value of x naught is equal to, suppose x naught dash, value of x is equal x naught dash, then you will get y naught dash. So this is two condition. This is two condition at a point. You may this condition also. Now this is initial value problem. This is not boundary value problem, because ये x naught नहीं है. So y dash of x naught after differentiating, let us suppose यहाँ पे example पे, so here you look y is equal to x square. This is a function. इसका first derive differentiate this function. This will be twice x. That means now the initial condition is, first initial condition is y of x naught is equal to y naught. That means put here x naught and you will get y naught. Okay, first after differentiating, this is y dash, put here x naught and you will get another value of this y naught dash. Suppose this is 1 point initial condition, because the condition given at only 1 point, that is x naught. Now 2 point, the condition may be given at 2 point also. Let us suppose first condition is given y of x naught is equal to y naught. Second condition is given y of c naught is equal y like this. Hi, this is suppose x naught. Yes. So x and x naught, that's these two are different point. So this is 2 point. This is suppose this is y dash. Okay. हाँ नहीं दिया तो भी होगा डिफरेंशियल नहीं क्या वही वहां पे without differential yes. So this is an initial condition. Suppose another is this x naught dash is equal 1. So in 2 point you are given condition using 2 point x naught and x naught. This will be boundary value problem. Okay. Let us go to an example. Look into here. This is differential equation. Here using 2 point, first point is 0 and second point is pi by 2. This is 2 point boundary value problem. Okay. Now find the solution of this differential equation. Now find first the general solution given differential equation is d square y by dx d2y by dx2 plus y is equal 0 and condition given is y of 0 is equal to 1 is given differential equation is this. These are the condition. Okay. These are the initial condition. Two initial condition. Given differential equation is this and initial conditions are y of 0 is equal to 1 and another is y dash of pi by 2 and this is equal to I. This now you have to find a solution. So what will be that solution? Let us think about solution of this differential equation. The solution will be since y is equal to, think about what will be the function whose second time derivative, this means what d square y divided by d2y by dx2 is equal to minus y. That means y is equal to, so minus 1. Think about a function, this is equal to this, right? Yeah. Think about a function, think about a function y such that second time derivative of this function y, second time derivative of this function y is negative of this function. Okay. Since second derivative of cos x is equal to minus cos x, hence y is equal cos x is a solution of this differential equation. Plus c, let us add here an arbitrary constant c. then it will be general solution. Hence, cos x plus c will be a general solution of the differential equation. It will be a general solution. Okay. Now, apply this initial condition from initial condition. Y of 0 is equal to 1. This will imply put value of x is equal to 0. Cos of 0, c is equal to 1. That means cos 0, 1 plus c is equal to 1. We will get c is equal to 0. C is equal to 0 satisfies this first initial condition. That means you can put here c is equal to 0. Second, y dash of pi by 2 is equal to 5. This also should be happen. What is y dash? Y is equal to cos x. Then y dash will be if this is y dash. Since y dash is equal radius of cos x minus sin x. You need such a solution whose values at 0 is equal to 1 and at pi by 2 the y dash नहीं है y at pi by 2 ये y लीजिए dash आता ना y dash that means ये derivative था तो derivative को हटा दो. Okay, and at pi by 2 the value of this value is 5. So sec x is equal pi by 2 put x is equal pi by 2. This will imply cos pi by 2 is equal. What is the value cos pi by 2? This will be 1, this will be 0 and this is 5. Is it possible? That means this initial condition, this differential equation with this initial condition have no solution. That means when you are going to give a boundary value problem, then you should be conscious. You should be mind about this. Okay. So let us make a boundary value problem here. Since here, what is giving us problem? This condition is giving us some problem to finding this solution. So let us change this condition. No. Yes. So y of pi by 2 is equal to 5, but here this is no problem. Cos pi by 2 plus is c. Let us put c. Okay, this is equal to 5. That means this is 0 plus c is equal to 5. Then means we are getting c is equal to 5. Here c is equal to 0, c is equal to 5. Also this is it. This is okay. C is equal to 0, c is equal to 5. We are giving 2. This is a problem also. Now what you will source here? Okay, so let us giving here. This is derivative. Okay, y dash of pi by 2 is equal to 5. Then what happens? Y dash change this initial condition. Here this is no derivative. Okay, the value of y at pi by 2, we have to change this should be 0. Then we will have a solution. So here it should be 0. So this condition does not have any solution. When you put here 0, you will get what? You will get y pi by 2. That means cos pi by 2 plus c is equal to 0. That means it will be 0 plus c is equal to 0. That means c is equal to 0 here also. So when this boundary value problem has a solution, hence the solution is y is equal to cos of x, c is equal to 0 plus 0. So this is the solution that satisfies this boundary value problem. Okay. So I hope you know what is initial value problem and what is boundary value problem. You have already obtained what is this. So thank you for today. You can subscribe the channel also. Okay, thank you. So in the next lecture we will discuss existence and uniqueness of initial value problem, existence and uniqueness of solution of an initial value problem of first order differential equation. So milte hain, see you in the next video. Thank you.